Good morning or good afternoon, guys. Today we're going to learn about constant of proportionality. And I remember my first year when I was teaching this, I had to learn how to say that in Spanish. And let's see if I can say it well. Constant of proportionality is, I already forgot the word for constant, but I know proportionality is proporcional. You guys should be very proud of me. Yes. All right, so when we learn about constant proportionality, we are talking about proportions. Okay, we're talking about if something is proportional, how will the graph look? So if something is proportional, the graph will be a straight line going through the origin. So if I were graphing, this is my x and y plane, my x and y axis. And if I had a line that was proportional, it would be a straight line or a line going through the origin. And if you forgot what the origin is just where 0 and 0 meet. Perfect. So if you're ever given an example like this, and it's asking you which one of the two is proportional, just by observation, and if you had something like this, does this start at the origin? Does this blue line start at 0, 0? No. So this line, just by observation, we could say that it's not proportional, or it doesn't have a constant of proportionality. This one we would say this graph is proportional. All right, so you are going to be often presented with a graph or like a table. So let's just get right to an example. The example is going to ask you, let's see, does the table represent a proportional relationship? So does the table represent a proportional relationship? And then I'm going to draw the table out, and then I'll pause so you guys can finish writing this down. So I don't know if you guys remember, but when we write ratios, we write them in terms of y to x, y to x, y to x, y to x. And if you don't remember, those are the three ways you write your ratios. We're going to focus on the fraction form of the ratio. When we're talking about proportionality, most of the times we have our ratios as fractions, expressed as fractions, okay? So if we look at our table, you could probably observe that there's a pattern here. 2 times something is 10. 4 times something is 20. 6 times something is 30. 8 times something is 40. If you see the pattern, can you type it in the chat? What is everything being multiplied by? Like all the x's are being multiplied by the same number. Yeah, a lot of you guys did find it. You could say that you already found the constant of proportionality. They are all constantly being multiplied by 5. So like 8 times 5 is 40. 6 times 5 is 30. 4 times 5 is 20. 2 times 5 is 10. So since they're all being multiplied by the same number, that's the constant of proportionality. That's the pattern. So we could say, just right off the bat, the constant of proportionality is 5. But that's not enough. I want to show you guys a way to solve this without, like, if the pattern is not that obvious. The pattern could be a decimal. The pattern could be a fraction later on. So you might not always see a clear cut multiplied by 5 or multiplied by 3 or multiplied by 2. You might get a decimal. You might get a fraction. So you would start by making your first ratio, y over x. 10 over 2, 20 over 4, 30 over 6, 40 over 8. And it all comes back down to the simple concept of writing your ratios in the order from y to x. So I'm going to write my first ratio, 10 over 2. What's 10 divided by 2? 5. Cool. Now my next ratio, 20 divided by 4. What's 20 divided by 4? 5. Good. Now I'm going to write my next ratio, 30 over 6. 30 over 6. And we know that 6 goes into 35 times. And my last ratio is 40 over 8. That equals 5. Cool. So if you ever don't see a pattern, you can just write your ratios from y to x, y to x, y to x, y to x. And then you can find the pattern. Now let's say you were to get 5 for almost all of them, and then one of them wasn't 5. That means the table is not proportional. That means you don't have a constant of proportionality. So if you get something different, so if like this is 5, this is 5, this is 6, and then that's 5. That means that you don't have a constant of proportionality. It's not a constant, it's not a straight line, I guess, if you drew it out. Now here's another way. Here's another thing that I want you guys to be aware of. You can also write an equation. Since you found the constant of proportionality, you can write the equation. The equation that we use for proportionality is y equals mx. And m represents the constant of proportionality. COP, because I don't want to write constant of proportionality again. It is also called slope. And it is also called the unit rate in math. So this letter represents a number that's very significant. We can call it the constant of proportionality, we can call it the slope, we can call it the unit rate. And if you remember, unit rate is like the price. Like if we were talking about, let's see, like for 2 ice creams, I spent $10. For 4 ice creams, I spent $20. For 6 ice creams, I spent $30. And for 8 ice creams, I spent $40. So if we were talking about ice cream, and this is money, the unit rate or the constant of proportionality is how much it costs for 1 ice cream. So the unit rate, the constant proportionality, and the slope means that each ice cream is going to cost $5 in this example. So if we were going to write the equation, all you would have to do is plug in 5 where the m is. So y equals 5x. Because we found the constant of proportionality, therefore we can write the equation. All right, so if we were going to graph this, remember at the beginning I told you that when you guys graph a line of like something that's proportional. So here's the x-axis and here's the y-axis. And I'm going to mark, so for my x's, I'm going to put the value of, we're going to pretend we're talking about ice creams, okay? So for 2 ice creams, 4 ice creams, 6 ice creams, 8 ice creams. And then I know that 2 ice creams cost $10, so I'm just going to graph this as as it's given to me on the graph. Okay, so remember when I graph, this is actually a point, 2, 10. I can also write this as 2, 10, so that I can plot it on my coordinate plane. 2, 10. So I'm going to write it in green. So my first point is 2, 10. So I'm going to go to 2, go to 10. There's my first point. My next point is 4, 20. 4 ice creams cost $20. All right. Then my next point is 6, 30. 6, 30. And then my last point is 8, 40. 8, it's supposed to be a straight line, but because there's human error involved, it might not be a perfectly nice line. But let's go ahead and connect this through the origin. Let's see. So if you actually draw the picture out, you're going to see that this is a straight line passing through the origin, and it is the table is proportional. You found it by using ratios. You wrote an equation. You even have a picture for it. And the whole big picture is you just found how much one ice cream is. And it's consistently $5. All right, so I'm going to give you guys one more example, and then we're going to move on to some practice questions. Sorry. There we go. So it's the same type of question. Tell me if this table is proportional. So let's write one more table. You guys are going to get really quick at writing these tables. So we have our X and our Y values. And I think it gives us 4, 1, 2, 3, 4. And the top numbers are 1, 3, 5, 7. And the next numbers are 3, 7, 11, and 15. So the big question is this table proportional? Is the table proportional? We can graph it if we want. If we have Desmos, we can graph it accurately. I can teach you guys that later as well. Because if I sit here and I try to graph it myself, I could unintentionally make a straight line. That's why it's important to use software, because that's going to be the most accurate. So I wouldn't recommend graphing it to see if it's a straight line through 0, 0. I wouldn't recommend doing that. What I would recommend you doing, unless you're using Desmos, of course, what I would recommend you doing is checking the ratios. So let's write the ratios. So my first ratio is, remember, you write your ratios y over x. Okay? So my first ratio is 3 over 1. 3 over 1. That's my first ratio. Now, what does 3 over 1 equal? Tell me in the chat. What does 3 over 1 equal? 1 times 3 is 3. Yeah, so that's just equal to 3. So that means for this table to be proportional, all of the ratios have to equal 3 in order for this table to be proportional. Let's look at my next ratio. The next ratio I'm going to write in blue. 7 over 3. Oops. Uh-oh. 7 divided by 3. 7 divided by 3 is not a whole number. 7 divided by 3. 3 divides 7 twice. 6. You have 1 left over. You could put a decimal here. 3 divides 10 3 times. But it looks like you are going to get a what type of decimal? Do you guys remember what type of decimal this is? When you keep getting the same thing? Do you guys remember what that's called? Yeah, so it is a run-on type of decimal. It's run-on, but we call it repeating because every time you divide 3 into 10, you get a repeating decimal. It just repeats forever and ever and ever. So you put a line over what repeats. So I did that more as a review, but 7/3 is equivalent to 2.3. Does 2.3 equal 3? No. So is this table proportional? Is this table proportional? No. So you're done. You just have to say this table is not proportional. And then I'm going to say because B/C, the ratios are not constant. In other words, they're not all equal.